Okay, so solving this equation, we get this, right? And I'm sorry for all the erasers. You all kept making mistakes here. Okay? But you get this. Okay? So that's -1/4 plus or minus the square root of -7/4, right? Yeah, there's a distributive law. You know, all this divided by this means this divided by this plus or minus this divided by this. It's really like multiplying by 1/4. You understand the distributive law from that. I've mentioned this sort of thing before. Okay, so what's the square root of -7?
You can't have a square root.
Sorry?
You can't have a square root, right?
It's what now?
You can't have a square root, am I thinking of?
Oh, you can, but not with the real numbers.
Okay. It's imaginary, is that what you're saying?
Is what?
It's imaginary?
Yeah, you get an imaginary number, right? Well, let's just see how that works out. You should know this. I mean, you should have known it at least for a couple of days at some time just before you took an SOL where you didn't really have to understand it anyway, right? Okay? We can write this as a square root of -1 times, I'm going to do it this way. No, I got it this way. Okay, that's the square root of -1 times 7/4, right? And that's -1/4 plus or minus the square root of -1 times the square root of 7/4, right? Now, what's the problem here? Well, we got rid of the problem with the square root of 7. That's fine. That's a perfectly good number, even if we can't write it down exactly, right? But what about the square root of -1?
It's imaginary.
Yeah, it's imaginary, and it's very specifically the imaginary number I. Okay? Now we got to learn how to do arithmetic with complex numbers. How you add them, how you subtract them, how you multiply them, and how you divide them. So let's just start off with this one. What's I times 3 plus 4i? Give you a hint, you're going to use a distributive law.
3i plus 4i squared.
It's I times 3 plus I times 4i, right? You don't have to see where it's going, you don't have to see where it ends up to do this step, right? And if it's unfamiliar, you probably aren't sure where it's going to end up. Okay? And it seems fairly unfamiliar. It might have been a while since you've seen it, and again, you might not have had to learn it that well. Okay? So, well, I'm going to write I times 3 as 3i, because commutative law is going to work, okay? What are you going to do with I times 4i?
4i squared?
Yeah, it's going to be 4i squared, right? Well, what's I squared?
Square root of 1.
Again?
Square root of 1.
No, let's think about I squared. Okay, so let's say I squared. Square root of -1 times the square root of -1, right? Well, if you multiply the square root of a number by the square root of a number, what do you get? You get the number.
Yeah.
Like, what's the square root of 25? So if you multiply the square root of 25 by the square root of 25, what do you get? You better get 25. That's what the square root means, although that meaning is apparently lost on 2 generations of students now because they do it by punching buttons and don't even necessarily know that square root doesn't mean the same thing as square of. Okay? So don't be that student. Get that straight and get it straight now. Okay? Because y'all are too smart to go through life not understanding what square roots are. The concept I started thinking about when I was 7 or 8 years old, as soon as I learned a little multiplication, I kept having to remind myself because I was pretty stupid, but eventually I got the idea. Because I didn't have a stupid calculator in my hand to avoid having to think about what the heck it meant. Okay. Yeah, you're allowed to laugh. Okay. This is hyperbole, but not really. Okay, anyhow. So the square root of a number times the square root of a number gives you that number. It has to equal negative blame 1. Okay? Got it? Okay? Now, I could go to advanced topics and ask you what I cubed is, or I to the 4th, or I to the 5th. Okay? Well, your book's going to do that, and you're going to have an assignment. Okay, anyhow. And it's an assignment that nobody ever has any trouble with except for the division. So, let's see, let's get through this. Okay, so this is 3i plus 4 times negative 1, which we would generally write as negative 4 plus 3i, because we generally write the real number before the imaginary number. Okay? Now, does anybody have a serious problem with this? Because that's all you really have to know. Okay? Now, in the MCR, I spent some time on these things, and I'm going to, link you to those videos in case you need them. Okay? Now, the one trick is division. Okay? So what if I wanted to do like 2 plus 7i divided by negative 4 plus 3i? Well, once you do the homework, you'll understand this. I multiply by what's called the complex conjugate. Notice when I did this, I have a real number plus or minus an imaginary number, right? If I multiply those two, I get a real number. Okay? So if I multiply this by its conjugate, I'm going to have a real number in the denominator. I don't want an imaginary number in my denominator. So I multiply by the complex conjugate, which is negative 4 minus 3i. It's the other one you would get if you got this out of the quadratic formula, right? Because the quadratic formula is going to give you a plus or minus. Okay? That's what the complex conjugate is. Okay? And this equals, and I'm just going to go ahead and work it out because now it's just distributive law. Okay? And I'm not going to do the distributive law, you do the distributive law. Okay? And verify that you get, let's see, 2 times negative 4 is negative 8, 7i times negative 4 is negative 28i, 2 times negative 3i is negative 6i, and 7i times negative 3i is negative 21i squared, divided by 16, how am I going to do this? Minus 12i plus 12i minus 9i squared. Okay? Try to get these written down correctly the first time since I'm so careless. And everything was good except that 2, really kind of a bad 2. Okay, so here we have this. This simplifies very easily, right? How would I simplify the numerator? There are two really obvious things we have to do to simplify the numerator. What are they? What's one of them? I don't care which
Combine
one.
like terms.
Again?
Combine the like terms.
Yeah, you got a negative 28i and a negative 6i, right? Okay, so let's combine like terms. Now we could have taken care of I squared at the same time, that's the other thing, but we'll do that next. Okay, and down here we combine like terms. Well, we have a negative 12i and a 12i, they go away, right? So we have 16 minus 9i squared. Now, we just established that I squared is negative 1, so we have negative 8 minus 34i plus 24 times negative 1, all divided by 16 minus 9 times negative 1.
There should be a 21i squared, isn't it?
Yeah, I copied it down wrong. Thank you. I repeat at least a dozen times a day, keep an eye on that. Okay? And then we say that's negative 8 minus 34i minus 21 over 16 plus 9. And then we have like terms, negative 8, negative 21, and we get negative 29 minus 34i divided by 25. And right there is a perfectly good complex number in simplified form. And that's the result of dividing this by this. Okay? That's how you divide complex numbers. And all you have to do is remember to multiply numerator and denominator by the same thing. You're used to doing that. And that same thing needs to be the complex conjugate, because if it is, you'll have a minus and a plus on the i's here that cancel out, basically. I used a bad word. That add up to 0. Okay? Fair enough?